Alright, so this is number 10 on the practice test. And let me just fix the camera here a little bit. Okay. So, it says, what is the major product of the following reaction sequence, right? So they give us this molecule, it's an alkyne. And they said first they're going to treat it with hydrogen and a hydrogen dihydrogen molecule and Lin-Lars catalyst, right? And then they're gonna do the second reaction that they're gonna do is they're going to add two bromines in what's that called? CCl4. I can't remember the name of it right now. Okay, so the first step is the creation of a Z-alkene. Okay, Lin-Lars catalyst is going to break up the alkyne into a Z-alkene, meaning that these two sections on the side of the alkyne are going to be cis to each other. Right, so step 1 is the creation of a Z-alkene. So I have, here's my molecule again. I treat it with hydrogen and Lin-Lars catalyst, and I get a Z-alkene like this. So they're on the two branches off the alkene are on the same side because it was syn addition of the hydrogens, right? The syn addition of these two hydrogens using Lin-Lars catalyst created the Z-alkene, where these two groups come in the same direction. So step 2 is the addition of bromine to the alkene, right? So I have a Z-alkene. The pi bond is going to act like a nucleophile. It's going to attack this bromine. The bromine it's in carbon tetrachloride. That's carbon tetrachloride. So the pi bond is going to attack the bromine and then take it, and this bond will break. So what we're going to get is this molecule with that characteristic transition state when you're adding a halide to a double bond. And then we have the bromine, right? So this is going to be an anti-addition. It's going to be, so this bromine molecule can now attack from here A, or it can attack from here, B, and whichever carbon it attacks, bromine's going to go to the other one. Now, here we have the possibility, this is going to make enantiomers because this carbon's going to be attached to a bromine, a hydrogen, an ethyl, and then this whole other group over here. So it's stereogenic, and this carbon is stereogenic too. So the question is, what's going to be created here? So very quickly, let's see if this works on the camera. I don't know if you can see the color. These are blue. Yeah, you can kind of see it. They're blue. Maybe red ones would work better, actually, to say. Yeah, you can definitely see red better. Alright, so here the molecule we have, this is the Z alkene that we have, right? Here's the ethyl group, the ethyl group, and then the other group, and they're in a Z double bond just like this. So if the A is going to attack this carbon, so let's say it comes and it attacks this carbon. This is the bromine that's attacking. The other bromine is going to go to the other carbon over here and go to the back. It's anti-addition, and then the bond that forms will be like this. And we'll have, if we put everything in the plane, let's see if we put everything in the plane of the atom, like they show in the picture, we get the two bromines coming out at us, and when you do this is S, this is S, yeah, this is S, so it is, A gives us this molecule down here. Right, so A gives us remember the two bromines were coming out at us, and they were both S. Now, I think this is what that's the image that they show on the practice test. And then, just so you know about the enantiomer, we'll go back and we'll start. Here we have okay, so here we have the alkene, right? The double bonded alkene. Now, if it takes the B path, if this bromine takes the B path and it attacks this carbon here, then this bromine's gonna come to the back. It's anti-addition, so it's gonna be on the other side. It's gonna be on the other side, like so. It's like this, right? And then you just put the bond in. We put the bond in, and this time when we make it look, when we get it like this, the two bromine atoms are going away from us, right? They're going away. So that makes them, this is R, okay, it's not really, you can't really see it that well. This is R. So that's how we get the enantiomer B. So the answer is A because it gives us this. It gives us this molecule right here plus plus enantiomer. So the answer on the practice test is A.